Hello everyone, you're welcome back to CnHn Academy. In today's video, as we also understand that our Jamb is only left with just only 8 days to Jamb now. So due to that, I noticed that many students have been struggling hard to understand the subject chemistry, most especially the topic organic chemistry. So due to this, I've come across, based on my research in the past years in Jamb, I've come across 40 most likely questions that you can likely see under Organic Chemistry 1 in Jamb. In my next video, I'll be bringing to you another 40 most likely questions on Organic Chemistry 2 in Jamb. I'm sure that if you'll be able to study this question might likely to occur again. Why? Because they set it in the recent time, and some of them have been set like 3 years back, 4 years back. Some of them are reset, and Jamb repeats some of their questions. So because we said Jamb repeat question, it doesn't mean that you should memorize all questions in your past question. The only thing I'm bringing to you here is that I'm really explaining to you how you can go about the questions and the answer. I'll be giving you the perfect answer to the question in this video. Please, if you are new to my channel, don't forget, click on the subscribe button to subscribe to my channel. And also, if you enjoyed the video, do try to share the video with your friends and family to help us. Please drop a like for us so that this video can go viral to what many people can also watch the video across the country. Thank you so much. Let's continue with the first question. Question number 1 that I've found so far. The first question that I saw is, alkanes are used mainly, that is the use of alkane. Alkanes are used mainly, option A, in the production of plastic, option B, as domestic and industrial fuel, option C, in the textile industry, option D, in the hydrogenation of oil, and option E, as fine chemicals. Now let me make you understand something is that majorly alkanes are used majorly as a domestic and industrial fuel. Now, most of your domestic fuel, we are talking about your petroleum, your diesel, your kerosene. These are domestic, and we also have industrial fuel altogether. So one of the major uses of alkane are used as a fuel. That's one of their major uses. Altogether, we can also use them as other like chloroform. We can use them as antiseptic also. Anesthetic. We can use them as an anesthetic. But the major use in this question here, they are used in domestic and industrial fuel, which is option B. That is my question 1. Question 2 that I find so far is, they said the following gases decolorize bromine water except. Now let me give you one thing about this question 2. They said which of the following gases decolorize bromine water? Bromine water can only be decolorized by, take a look at this. Bromine water can only be decolorized by unsaturated hydrocarbons. Hello? Unsaturated hydrocarbon decolorize what? Bromine water. Unsaturated hydrocarbon. Now, this unsaturated hydrocarbon can either be ethene, altogether, it can be what? Ethane, and it can be benzene. Are you getting what I'm saying now? I'm talking about the not only ethene, alkenes in general. Alkenes, alkynes, and then aromatic hydrocarbon. Aromatic. Now, majorly, the major reaction of these 3 organic compounds is that they can easily be distinguished from alkane. I get something now. They are easily distinguishable from alkane using bromine water. So the 3 of them are going to decolorize bromine water altogether. So in the question, they said the following gases decolorize bromine water except. Now we are given option A. We have C2H6. Option B, we have C2H4. And option C, C2H4, option C, we have C2H2, and then option D, we have C3H6. Now, let me try to explain what is there for you. C2H6 is having the general formula of CnH2n+2. And if I have a general formula of CnH2n+2, that should give rise to ethane. Ethane, which is an alkane family. Ethane. So this C2H6 is an ethane, and don't forget, it is only these 3 that can decolorize bromine water: alkene, alkyne, and benzene, which is aromatic hydrocarbons. Altogether like that. So this one here is an ethane. I think it's an ethane. If I find it, I have CnH2n-2 altogether. So if you substitute this, I have C2 when n is 2. I have H2 times 2 minus 2, which is C2H. 4 minus 2 should be 2, which is ethane. Ethane will also decolorize bromine water altogether. Now, decolorization of bromine water by all these three are known as additional reaction. So they can distinguish between alkanes and all this one using what? Addition reaction. So all this one undergo addition reaction, while alkane does not undergo addition reaction. So if you take a look at this also, they say this is what? Propane. Why this one is ethene. This is ethene. Altogether. So it is only this which is what? Ethane that does not decolorize bromine water. I hope you understand this. That is my question 2. Question 3 that I've searched so far. Altogether, please take your pen now and be noting this important thing, because this thing might likely occur back to you in exam. Before you solve, take a look at the option very well. This kind of question I just give you just now, you answer it based on the option. And if you don't understand the general formula, you can't get it. The general formula of alkane is CnH2n. This is alkanes. Where n is the number of carbons. General formula of alkane is CnH2n. This is alkene. Whereby I have what? Alkenes. And the general formula of alkyne is CnH2n-2. Alkynes. General formula of benzene is CnH2n-6. That is benzene. This is aromatic benzene. Aromas. Altogether, aroma. So these are the general formula. Where the n is the number of carbon, you just check the number of carbon. Don't stress yourself. The number of carbon is in front of the carbon in the option. This carbon is to show you that what you have 2 carbon. Then substituting into any of this formula, you know what we are talking about. Altogether. Now let's take a look at what? Question 3. Question 3 is all about alkane. They said catalytic hydrogenation of alkenes. Catalytic hydrogenation. Don't let them stress themselves by disturbing with English. When I said catalytic hydrogenation, they are referring to what? Hydrogenation. And anything, whenever you hear the word hydrogenation, or you hear the word halogenation. Now, these two are addition reaction. And the function of this hydrogenation and halogenation majorly are used to convert unsaturated hydrocarbon to a saturated hydrocarbon. Now, these three that I gave to you here, alkene, alkyne, and aromas, they are unsaturated hydrocarbons. While alkane is a saturated hydrocarbon. So if I want to convert from all this one to this, we use either hydrogenation or halogenation. Now, what's the meaning of hydrogenation? Hydrogenation simply means addition of hydrogen. Addition of what? Hydrogen. If you add hydrogen to it, let me show you something here. Normally C double bond C. This is ethene. Ethene is having here H, and H. Now, what is missing in ethene that differentiates ethene from ethane? Ethane is going to give me C, H, and H. Now, what differentiates ethane from ethene is that what? Removal of hydrogen from this bottom here. Altogether, hydrogen has been removed from this point here. So, if hydrogen is being removed, that means if I now add, I can add that hydrogen back. Addition of that hydrogen only remove this bond and turn it a single bond. Then hydrogen will be what's added. This is what we call hydrogenation. And how is that done? By just, if it's double bond, by adding plus H2. So if I add hydrogen to this, hydrogen is going to replace the position here to form what? Ethane. So we can call this thing catalytic hydrogenation. Catalytic, breaking down of ethene, which is unsaturated, to a saturated hydrocarbon. I think that is my question 3. Let's take a look at our option. Catalytic hydrogenation of alkenes produce compound with the general formula. Now take a look at something here. They want to confuse you. That's why they put this general formula. To know if you really understand. Compound with the general formula. Option A, we have CnH2n plus 1 OH sorry. Option B, we have CnH2n plus 1. Option C, we have CnH2n-2. Option D, we have CnH2n+2. And then we have CH3CH and Y. Now, look at it. These are the options. Now, the only one to know, maybe you understand chemistry. And what are they trying to do? They said the catalytic hydrogenation of alkenes. Don't forget that I said if you hydrogenate alkenes, it's going to come back to what? Alkane. Why? Because alkenes are unsaturated hydrocarbons. So alkane, the general formula for alkane is CnH2n+2, which is option D. Now you see this one here is alkanol, because there is presence of hydroxyl. This is alkanol. This one is only alkyl. Why this one is ethane, alkyne. And this one is carbohydrates. So the general formula, which is alkane, this is alkane. This is my answer, alkane. Altogether, I'm sure I'll be able to explain this better for you. Thank you so much. Question 4. This is my question 3. Question 4 that I've seen so far is on alkanol. It said alkanol have unexpectedly high boiling points relative to their molar mass because of intermolecular works. Now, take a look at something. You see, all the organic compounds, with the exception of alkanol and carbohydrates, I get something that are insoluble in water. That means they are not soluble in water. They are non-polar solvents. Altogether, now only alkanol and carbohydrates are soluble in water. And why? The reason why they are soluble, the reason what causes their solubility is because of the presence of hydrogen bond that is found in them. Altogether, and this hydrogen bond also gives them their high boiling points that they have. So they have high boiling points due to the presence of what hydrogen bond that they have. Now look at the question on the hand. It said alkanol have unexpectedly high boiling points relative to their molar mass because of the intermolecular what? A, hydrogen bond, B, metallic bond, C, covalent bond, D, ionic bond, E, van der Waals bond. Our answer is what? Hydrogen bond. It is due to the presence of hydrogen bond that they have that makes them to have high boiling points. Altogether, I think I've been able to give you 4 questions now, and we are going to 40. Question 5 that I've seen so far in this. Please take note of this question. Question 5 is, which of the following hydrocarbon is unsaturated? Now, we knew that unsaturated hydrocarbons are either alkene, alkyne, or aromas. Aromas are benzene. Those don't say benzene. I get something like benzene. They are aromatic, they are unsaturated hydrocarbons. Now, which of the following hydrocarbon is unsaturated? We have option A, ethane, option B, benzene, option C, propane, option D, 2-methylbutane, so far it is in. Option E, 2,2,4-trimethylpentane, A. Are you getting what I'm saying? So my answer to that, you notice that the rest of them are alkane. For that they are saying 2,2,2,2. The only one that is there that is an aromatic, that is unsaturated is what? Benzene. Are you getting me? Is what? Benzene. So my answer to that question is benzene. Question 6. That's my question 5. Question 6. Consider the reaction below. I think they said we have this reaction CH2 to give CH3 CH, this is OH, and then I have CH2OH. Now, what is this? What is this? This is propane. Propane. Why this one is ethane 1,2-diol? Sorry, propan 1,2-diol. 1,2-diol. Propan 1,2-diol. Now, what is the question? This is a reaction. What kind of reaction is this? We want to know. The question that it asks is, which of the following reagent is used for conversion indicated above? Now, let me give you one thing here. Now, this reaction that you are seeing here is otherwise known as an oxidation reaction of ethene. Oxidation reaction. Oxidation reaction of ethene. And oxidation of ethene, this is ethene here, double bond, ethene. Oxidation of ethene is always done by addition of KMNO4. That is potassium permanganate. Addition of potassium permanganate to ethene. Are you getting it? The complete reaction gives rise to propan 1,2-diol. Are you getting now? So if you what this is this is propane, not ethene. This is propane. Now if propane is being oxidized, it is oxidized to what? Propan 1,2-diol. So look at the question. So which of the following reagent is used for conversion indicated above? Altogether, A, we have what? Aqueous sodium hydroxide. B, acidified potassium tetraoxomanganate 7. This is what we call acidified potassium tetraoxomanganate 7. Option C, ammoniacal copper 1 chloride solution. Option D, aqueous ammonia. And option E, dilute reducible 6 acid. So our answer is what? KMNO4, which is acidified potassium tetraoxomanganate 7. That is my question 6. Now let's move on to question 7. Question 7 that I've seen so far in Jamb is this. They said, which of the following exhibits resonance? Now, you see the word resonance simply means existence of a single compound in a dynamic equilibrium. When a compound can exist in dynamic equilibrium with itself, we call it what? Resonance. Are you getting me? And the only compound that does that is benzene. Benzene, take a look at something. Benzene can act in this manner. I will have something like this. Now I can have this. Don't forget that the bonding are what? Interchange by leaving space. Now we can have the bonding like this, or I have the bonding like this, and this. Now take a look at this position. The position of the bonding is here and it is here. Are you getting something now? Look at, and look at. So these are equivalent to each other. This is still benzene and this is what? Benzene. So we can write benzene like this. We can have, so the process whereby benzene can exist in different form like this. This is all called resonance. This is in dynamic equilibrium. So they said, which of the following exhibits resonance? They ask this question often. Repetition of this question. So you might also be lucky to have this question again. They said, which of the following exhibits resonance? A, benzene. B, butane. C, pentane. D, octane. And E, hexane. The answer should be benzene. Are you getting something now? So it is benzene that undergoes that. That's my question 7 altogether. Now let's move on to question 8. We're going to question 40. Question 8. Let me take a look at the question 8. Now it is ethene undergoes mainly addition reaction. Why is it that ethene undergo addition reaction? That's what they are trying to ask us here. Okay, let me go. They said ethene undergoes mainly addition reaction because it is A gas, B, a hydrocarbon, C, unsaturated, D, easily polymerized, E, a covalent compound. Now, ethene and ethane, they undergo addition reaction because they are unsaturated hydrocarbon. Unsaturated. Why? Don't forget I said addition reaction can be used to differentiate between unsaturated and saturated hydrocarbon. So the reason why ethene undergo addition reaction is because of what? They are unsaturated. So answer to that is option C, which is what? Unsaturated. Question 9. Question 9, please be jotting this down. Question 9 is that what? Which of the following is a secondary alkanol? I'm going to be breaking this down for you, also for you to understand what is there. And in case you might see likely question like that in exam, you are going to know what to choose. So which of the following is a secondary alkanol? We have option A, let me try to write it out. CH3, CH2, then we have what? OH. Option B, CH3CH double bond, CH2, and I have OH. Option C, I have CH3, CH2, this is 3OH. Option D, I have CH3, CHOH, and then CH3. Option E, I have C, CH3 and 3, and OH. Now, how do you indicate? Now, you see, alkanol are classified based on the position of their hydrogen. Are you getting something now? We can classify alkanol based on the position of what? Hydrogen. Now, based on that, alkanol are classified into 3. Here we have a primary alkanol, we have a secondary alkanol, and we have the tertiary alkanol. Now take note of this. Now we have a primary, a secondary, and a tertiary alkanol. Now how do you distinguish between all of them? Primary alkanol are majorly the hydrogen group must be attached to one carbon with two hydrogen. The hydroxyl group must be attached to what? One carbon with two hydrogen. Are you getting something now? Now, while a secondary alkanol, in secondary, the hydroxyl group must be attached to what? One carbon with one hydrogen. One carbon with one hydrogen. While in tertiary, the hydroxyl group will only be attached to carbon without any hydrogen. Carbon without any hydrogen. Let me showcase in this place here. Now, let's try to what? Analyze what is there. This one is indicating that CH3, let me write it out for you. CH3, this is C, 1, 2, 3. Now this is CH, C1, 2H, 2, then OH. Now, in this case here, the carbon, look at the hydroxyl group, is attached to a carbon with two hydrogen, which indicates primary alkanol. Two hydrogen, primary alkanol. Now, assuming, okay, let's take a look at option B. In option B, it's just a double bond. So if you take a look at it, this is the OH. It is attached to this CH2, which is how many hydrogen? Two hydrogen. The hydrogen is attached to the carbon with two hydrogen. In option C, this is the hydroxyl. The hydroxyl here is attached. Let me write this thing out for you. CH3. If I go to this place, this is CH2 in three places. CH2, CH2, and then CH2. That's what the same is. Then OH. Now, this is the OH attached to this carbon with two hydrogen. Are you getting something? Now, first of all, I splitted this to understand. In option D, we have CH3, CH, C, H, and OH, then CH3. Now, this is the OH attached to this carbon. But that carbon is having one hydrogen. And don't forget I said, if OH is attached to a carbon with one hydrogen, that is indicating secondary alkanol. Without any hydrogen, it indicates tertiary alkanol. I'm sure that you've understood what I just said just now. So what's the answer to that? That's our question 8. The answer to that is, he said, which of the following is a secondary alkanol? So the answer was option D, which is our question 8. I think we are good to go. Let's take a look at question 9. Question 9. Okay, sorry, that's our question 9. Now let me take a look at question 10. Question 10. Okay. Now the question 10 goes thus. It said, alkanes react with halogens mainly by what? Now you see the major reaction of alkane, with the exception of all hydrocarbons, their main reaction is combustion reaction. All hydrocarbon, their major reaction is combustion reaction. But every hydrocarbon has a specific reaction. As in unsaturated, we know that their specific reaction is addition. While alkane, their major reaction is substitution. Altogether, so alkanes react with halogens mainly by what? A, oxidation, B, polymerization, C, addition, D, reduction, and E, substitution. Our answer to that is substitution. Hope we understand. Before I move on with the question, please take your time to help us. Click on that like button that is there below to like my video, and also subscribe if it really helps you. Subscribe and share with your friends. Thank you so much, because it's going to help us to have it's going to help me with YouTube algorithm. Thank you so much. Now let's take a look at the question 11 that I've seen so far for you based on my research. Question 11, they said, okay, which of the following alkanes has the highest boiling points? Which of the following alkanes has the highest boiling point? Now take note of something. The boiling point of alkane increases with an increase in the number of carbon. That means when the number of carbon increases, their boiling point also tends to increase. Now, look at it. Option A, we have pentane. Option B, we have ethane. Option C, we have propane. Let me write something. Mets simply means one carbon. X simply means 2 carbon. Prop simply means 3 carbon. But simply means 4 carbon. Pent simply means 5 carbon. X means 6 carbon. Now, as the number of carbon are increasing, that's how their boiling point is also increasing. So, which of them will have the highest boiling point? Option A, we have pentane. B, we have ethane. C, we have propane. D, we have butane. And then E, we have hexane. Our answer should be what? Hexane. Hexane has the highest boiling point, and also it has the highest melting point. Altogether, so melting point and boiling point of organic compound increases as the number of carbon increases. but their volatility tends to decrease when their their solubility tends to decrease when the number of carbon increases. I want you to get on me like that. Now, that is my question 11. Question 11. Now let's take a look at question 12. That I've seen so far. Question 12. We're moving on. Question 12. We said, which of the following can undergo both addition reaction and substitution reaction? Now, you see, the major distinction that you can use to distinguish aromatic hydrocarbons from aliphatic. Aliphatic hydrocarbons are your alkanes, alkenes, and alkynes. I want you to get that. Now, in this question, it said, which of the following can undergo both addition reaction and substitution reaction? Addition reaction and substitution reaction is the major reaction of benzene. So you can easily distinguish between a benzene and alkene and other unsaturated using substitution reaction. Benzene is going to undergo substitution reaction, while other unsaturated hydrocarbon does not undergo like benzene. Are you together? So they said, which of the following can undergo both addition reaction and substitution reaction? Option A, benzene. Option B, pentane. Option C, propane. Option D, hexane. And then E, ethene. The answer should be benzene. Now, do you know the reason why ethane is not placed in the option? Because ethane can also undergo substitution reaction only in one condition. Ethane undergoes substitution reaction with its own terminal carbon. That means the first carbon. So if the ethane is a terminal carbon, then it will undergo substitution reaction. But if the ethane is not a terminal carbon, that means if the double bond is on a terminal carbon, it undergoes substitution reaction. But if the double bond is not on a terminal carbon, it does not undergo substitution reaction. So please take note of that. So my answer to this is benzene. Benzene can undergo both addition and substitution reaction. Now, question 13. Question 13. What is the next question? They said dehydration of ethanol produce what? Now, when you dehydrate ethanol, dehydration simply means addition of H2SO4. The addition is what? Addition of H2SO4. Now, what are we going to do? We want to remove water molecule from ethanol. If water molecule has been removed from ethanol, it produces ethene. So the addition of ethanol is used in the production of what? Ethene. Altogether, ethene. So ethanol is being produced from what? Ethene is being produced from ethanol using dehydration by addition of H2SO4. So what is the answer to this? They said the addition of ethanol produces A, ethanoic acid, B, propane 1,2,3-triol, C, ethene, D, ethanol, and E, methanol. Our answer should be what? C, ethene. All together. Now, question 14 that I've seen so far. Now, trying to write everything out. Now, question 14. This is the question. They said, when alkanol reacts with sodium, the gas evolved is what? Now, when alkanol reacts with sodium, that's one of the chemical reaction of what? Alkanol. Now, alkanol, which is, let me say ethanol for instance, C3H8 plus sodium. Now, this undergo a displacement reaction. Are you getting what I'm saying? This is a displacement reaction. When sodium reacted with what? Ethanol, it displaces hydrogen away. Are you getting what I'm saying? To produce sodium ethanoate, C2H8 all together. Now, sodium ethanoate will be what? Sorry, C2H8 all together. Now, plus H2 hydrogen gas. Now, when you react ethanol with sodium, it gives what? Sodium ethanoate and what? Hydrogen gas. That means hydrogen gas will be given off in that reaction. Why? Because sodium is highly reactive than hydrogen. So it displaces hydrogen away from its what? Compound. Altogether. So the answer to that question 14 should be option A, hydrogen. Option B, oxygen. So answer should be what? Hydrogen gas. I'm sure that what? We understood this. Now let's take a look at question 15. Now, you see this question, I have explained in my previous video. I explained the naming of organic compound, but you notice that this compound also repeats itself. Are you getting in naming? Now, they give us something of this kind: CH3, CH2 C, double bond CH2. Sorry, I'm trying to make it faster so that what? To reduce the timing. I have what? CH3. Now, they say we should name this. They say, what is the impact name of the following compound? What will be the impact name of this compound? Now, how do you name? Don't forget, if you want to name. If you don't understand how to name, watch my previous video that I did on naming of organic compound. So I named this 1, 2, 3, 4. Now, the naming is here. This is 2 carbon, that is 2-methyl. 2-methyl. Now, the family name is 1, 2, 3, 4, which is butane. So, now, butane. That is butane. 2-methyl butane. So, my answer should be what? Or 2-methyl butane. Yeah, 2-methyl butane. That's the best thing. 2-methyl butane. That should be the best one. Or you can call it 2-methyl butane. So, my answer to this is 2-methyl butane. That is the answer to that. So, let's jump to question 16. Now, this question 16, I've seen this question and it's kind of confusing. What's the question? They say, which of the following compound is used as a gaseous fuel? Now, majorly, the compound that we normally use as a gaseous fuel, we have CH3COO CH2CH3 CH3CH2 CH2CH3. Okay, let me write it out. We have CH3COO CH2CH3. And then, sorry, I'm trying to read from what's past questions. CH3CH2 CH2 CH3. Then we have CH3. We have CH3 CH2 COOH, and we have CH3 C triple bond CH. Now, take note of something. Majorly, alkanes are used as a liquid fuel. All together. Now, you know one of the major uses of ethane is that what it is used as a fuel in a mineral lamp. So ethane is used as a fuel in a what? In a mineral lamp. So you see, ethane is used as a gaseous fuel. It's a gaseous fuel because it is gases. So in this case, you don't need to stress yourself. Just find a double bond. So ethane and propane, they are both gaseous fuel. So the answer to this is D, which is what? Ethane and propane. I get something now. So all these ones are not what this is, except what propane, which is used as a gaseous fuel. So that's question 16. Question 17 also. Question 17 also might look confusing. Look at the question. It said, how many carbon atoms are present in one molecule of 2-methyl propane? That is the problem. One molecule of 2-methyl propane. 2-methyl propane. How do you understand the number of carbon that is there? You can only understand that by drawing out the structure of 2-methyl propane. Propane is the family name by writing CC, 3 carbon. Are you getting what I'm saying now? Now, 2-methyl simply means the methyl group is on the second carbon, CH3. All together. So I can have here as hydrogen, but do you need that in exam? No. Hydrogen. Now, how many carbon is found in 2-methyl propane? They are not referring to the family name. How many carbon is on the family name? But they are referring to what is the general number of carbon there. We have 1, 2, 3, 4 carbons. So in 2-methyl propane, there is what? Total number of what? 4 carbon. Option A, we have 2. Option B, 3. Option C, we have 4. Option D, we have 5. The answer is what? 4 carbon. Now let's take a look at question 18 on this. Question 18, I think we are going so far. Question 18 is said, which of the following is the most reactive toward bromine? The most reactive towards bromine. Now take note of something. You know I said bromine is used to distinguish between unsaturated hydrocarbons. Are you getting me? And saturated hydrocarbons. But out ethane and ethene and benzene, the 3 of them undergo decolorize bromine water. Decolorize what? Bromine. But which of them is most reactive with bromine? The one that is most reactive with bromine is one that has the highest number of carbon. Are you getting something now? The one with highest number of carbon is most reactive with what? Bromine. And which of them is the most reactive? It is ethane. Ethane is the most reactive with bromine. Next to it is benzene. Then the least reactive with bromine is ethene. All together. So ethane is most reactive with bromine. Next is benzene. And the least is ethene. So the answer to that, option A, we have methane. Option B, we have benzene. Option C, we have ethane. And option D, we have what? Ethane. Our answer should be what? Ethane. Why? Because it has the highest degree of what? Unsaturation due to its carbon. All together. Thank you for that. Question 19. My question 19 that I've found so far is, which of the following compound is unsaturated? We can easily distinguish this. We have option A, we have 2-methyl butane. Which of the following compound is unsaturated? Option B, we have chloromethane. Option C, we have methylbenzene. Option D, we have 1,2-dibromoethane. 1,2-dibromoethane. Now, which of them is unsaturated? Now, please take note. Unsaturation can either be benzene, ethene, or ethane. So, all these ethane that is there, they are rubbish. So, my answer should be what? Methylbenzene. Methylbenzene is an unsaturated hydrocarbon. So, take note of that. Now, question 20. So far, so good. We have gotten to question 20. Now, question 20, they said, which of the following is a secondary alkanol? I think I've been able to explain this, so I shouldn't have much explanation on this. Which of the following is a secondary alkanol? Don't forget, I said secondary alkanol should be an alkanol that has its hydroxyl attached to a carbon with one hydrogen. So, option A, we have OHCl2 towards CH2OH. Option B, we have CH3C, double bond CH to CH2OH. Option C, we have CH3 CHOH, then CH3. Option D, we have CH3 CH2 CH2OH. Our answer should be option C, which is CH3 CHOH. Don't forget that the OH is attached to what? A carbon with one hydrogen, not CH2OH, but CHOH. So that's our answer to that. Now, that is our question 20. Jump to question 21. Question 21 said, geometric isomerism is exhibited by what? Now listen, geometric isomerism is one of the major isomerism that is undergone by unsaturated hydrocarbons. Are you guys listening now? So unsaturated hydrocarbon undergo what? This geometrical what? Isomerism, unsaturated hydrocarbon. Now, and the one that undergone it the most are the what? Ethene. Whereby we can have a 6 and trans isomerism. All together, take a look at this. They said geometrical isomerism is exhibited by what? We have option A. We have C2H2Cl2. We have C2H5Cl. We have C4H10. We have C5H12. Now, option C and D, this is option B. Option C and D should be removed from the what option. Why? Because both of them are alkanes. All together, this no C5H12 is not an alkane. C5H12, yes, they are alkane. So both of them are what? Alkane, because this is butane and this is what? Pentane. So remove it from the option. Now, in our C, this one here is a chloroethane. Chloroethane should be removed from the option because it will not undergo what? Geometrical isomerism. But if you look at this is C double bond C with 2 hydrogen. Geometrical isomerism can either be a cis or trans. So these 2 hydrogen can attach to like this Cn, 1 hydrogen, Cn, 1 hydrogen. Are you getting what I'm saying? Whatever it has been in this format, we call it a what? A trans isomerism. This is a trans isomerism. Now when it is in this format, C double bond C on Cn, hydrogen, hydrogen. This is a cis isomerism. This is trans. Trans simply means the compound, the elements, substituents will be in what? Opposite direction to each other. Why cis simply means the what? Substituents will be in the same direction. So it is only chloroethene that undergo substitution, that undergo geometrical isomerism in this option. So my answer should be what? A. That's our question 21. Question 22. I think we are going so far. Question 22. Question 22. We said, sorry. Okay, question 22 said, benzene produces more soot than ethene on burning because of what? Soot simply means a black smoke, a black smoke. Now they say benzene produces that because of what? This is because benzene has higher saturation of carbon. It is more unsaturated than ethene. But let's take a look at the option. Option A, they said A has a higher molar mass, B has a higher degree of unsaturation, C undergoes both solution and adsorption, D is a liquid. The reason for that soot that is produced is because of the higher degree of unsaturation that is found in benzene than ethene. So answer should have to what? Is option B. Now question 23. Question 23 is that what? They said, which of the following compound exhibits both structural isomerism and cis-trans isomerism? Please don't forget that what? Structural, any compound that undergo cis and trans simply means geometrical. They will also undergo structural isomerism. Option A, we have C4H8. C4H8 is butane. No, sorry. That is butane. Yeah, I'm correct. C4H8 is butane. CH3O CH3. I get it. That is methanol. Methoxymethane. Sorry. Yeah, methoxymethane. We also have a C5H12, which is what? Pentane. We have C6H, which is benzene. So the one that undergo a structural and geometrical isomerism is what? A, which is C4H8, which is butane. All together. Now, question 24. Question 24. They said when alkyne are hydrogenated completely, they produce what? Compound with the general formula. Alkyne. If you hydrogenate alkyne, you know it undergo addition reaction. I get it. And I say addition reaction can either be what? Hydrogenation or halogenation. So if you hydrogenate alkyne, it's going to produce, it's a two-step reaction. First of all, alkyne will be what? Reduced to alkene. Then further hydrogenation will make alkyne to be reduced completely, alkene to be reduced completely to what? Alkane. So that's why they use in this question as they said, when alkyne are hydrogenated completely, that is completely, they produce what? They will produce alkane with the general formula of CnH2n+2, which is option A, we have CnHn, option B, CnH2n+2, option C, CnH2n, and option D, CnH2n-2. So that is our answer, option B. Now, that is question 24. Let's look at question 25. In question 25, they gave us this question. They said, the following compound are hydrocarbons except. Don't forget that hydrocarbons are compounds of hydrogen and carbon only. There must not be any other compound like oxygen. There must not be any other element like oxygen or nitrogen or chlorine must not be there. So hydrocarbons are purely hydrogen and carbon. All together. Now they said the following compound are hydrocarbon except A, methylpropanoates. Propanoates will have COO, which is hydrogen. Option B, 2-methylbutane. Option C, benzene. Option C, cyclohexane. Our answer to that is what? Methylpropanoate, because of the presence of what? This OO that is there. All together. So methylpropanoate is not an hydrocarbon. All together, because of the presence of what? The oxygen that is there. So let's take a look at question 26. Question 26 said that was the reaction between ethene and chlorine to form 1,2-dichloroethane is what? Now, don't forget I said ethene is an unsaturated hydrocarbon. When you add chlorine to it, I get something now. If chlorine is being joined to what? Ethene, that is an addition reaction. It makes ethene to form 1,2-dichloromethane. That is an addition reaction. So option A, we have oxidation reaction, B, polymerization reaction, C, addition reaction, and D, substitution. Our answer should be what? Addition reaction, which is the major reaction of what? Alkane. I hope we're what? Moving on. That is our question 26. Now, let's take a look at question 27 that I've seen so far in Jamb under the first organic chemistry 1. Now, I think this question is just common. Octane rating. They said a given fuel has an octane number of 100. This means that A, the knocking tendency of the fuel is low. B, the fuel is a mixture of several hydrocarbons. C, a large amount of alkanes is present in the fuel. D, the fuel needs to be cracked before use. Our answer should be what? The knocking tendency of the fuel is low. Are you together? So that's what we call octane rating. So the fuel with an high octane rating has a low tendency to what? Knock. I get to neglect what? The engine that the fuel is what? Being found. That's our question 27. Now question 28. Question 28 is when excess ethene is shaken with acidified potassium permanganate 6, permanganate 7 solution, the product obtained is what? Don't forget I said when you add ethene to potassium permanganate, it is an oxidation reaction. And in any oxidation reaction, the final product is ethane 1,2-diol. Ethane 1,2-diol will be produced all together. So there's no time you should have what? Written the what? A reaction for you. but no time for that for now. So Ethane 1,2-diol is produced. Option A, we have ethane. Option B, we have ethanol. Option C, we have Ethane 1,2-diol. And option D, we have ethanoic acid. So answer is option C. That is my question 28. Now let's take a look at my question 29. So far, under organic chemistry 1, question 29. Hydrogenation of C6H6. Complete hydrogenation of C6H6. C6H6 is benzene. When you hydrogenate benzene in the presence of nickel catalyst, and take notes, hydrogenation always occurs in the presence of a catalyst, which is nickel catalyst. But when you hydrogenate benzene in the presence of nickel catalyst at a temperature of 200 degrees Celsius, it produces cyclohexane. Cyclohexane. That is the only additional reaction that benzene undergoes. And benzene majorly undergoes substitution reaction, but it can undergo additional reaction with hydrogen and chlorine. Are you getting me? So when you hydrogenate benzene, it produces what? Cyclohexane. Hope you'll be like that. So answer option A, we have C6H6. Option B, we have C6H10. Option C, we have C6H2, which is hexane, but in the form of what? Cyclic manner, cyclohexane. And option D, we have C6H14. C6H14 is a normal hexane. Altogether, C6H12 is cyclohexane. What connection between normal hexane? This is a straight chain, and this one is the cyclo one. Now, the difference between a straight chain and a cyclic hydrocarbons are there's a deduction of 2 hydrogen. This is 14, this is 2 H12. Altogether, so that's my question 29. Question 30, so far, so good. Because we need budget. Is that what? They said which of the following compound would not give a precipitate with ammoniacal silver nitrate solution? Which of the following compound will not give a precipitate with ammoniacal silver nitrate solution? First of all, you ask yourself, what is the function of ammoniacal silver nitrate solution? Ammoniacal silver nitrate solution is used to distinguish between ethane and ethene. Altogether. Now, it is only ethane that will give a precipitate with ammoniacal silver nitrate solution, while ethene does not give a precipitate with ammoniacal silver nitrate solution. Option A, we have, you don't even stress yourself, just look for, we have, okay, hey, thank you, this is what I want to explain here. This question 30 brings me to what I want to explain. Now, you know I said earlier on that what? Ethane can undergo substitution reaction. It is only, this is, the substitution reaction of ethane, that's what we normally use to distinguish between ethane and ethene. Ethene does not undergo substitution reaction. But what kind of ethane undergoes substitution reaction? That's what they're asking here. It is not all the ethane that undergoes substitution reaction. The only ethane that undergoes substitution reaction is the ethane in which the triple bond is attached to the terminal carbon. This is what we call terminal carbon. The last carbon is what we call terminal carbon. So the triple bond is attached to the what? Terminal carbon. Anyone that has a triple bond attached to the terminal carbon is going to undergo substitution reaction with ammoniacal copper 1 chloride or ammoniacal silver nitrates. Are you getting what I'm saying now? So in this question, they say which of the following compound would not give a precipitate with ammoniacal silver nitrate solution? Would not. Let's take a look at the option. Option A, we have CH3 CH3 we have HC triple bond CH, we have option C, we have CH3C triple bond CH, and option D we have what? CH3 CH2 triple bond CH. Which of them will not give this triple bond? All of them are ethane, but which of them will not give a precipitate with ammoniacal silver nitrate? It is very easy. First of all, let's take a look at option A. The triple bond is attached to what carbon? Carbon 2, because it's carbon 1, this carbon 2. In this place, the triple bond is attached to what? Carbon 1. Here, carbon 1. Here, carbon 1. Are you guys understand? And we said it is not audio triple bond, audio alkane that undergo substitution reaction. The only alkane that undergo substitution reaction are the ones in which the triple bond are attached to carbon 1. If it is attached to carbon 2, this one does not give any precipitate with silver nitrate or silver chloride. Are we together? That means this one does not undergo substitutional reaction. That is what I want you to know. So that is my question 30. Please, let me digress a little bit. If you are new to my channel, I hope you are enjoying these questions and answer. And please, take down your pen and jot down everything with a better understanding. You don't need to cram it. Just understand what is there. Then you might likely see this question back in your exam. Now, please, if you are enjoying this video, please take your time to just drop a like for me in the like box, and just drop a like for me, and also click on that subscribe button to subscribe to my channel, and also share with your friends. Thanks so much. Let's continue. Question 31. 31 said, when ethanol is heated with excess concentrated ethanol acid, 31. When ethanol is heated with excess concentrated ethanol acid, tetrosulfuric acid, the organic product is formed is what? Don't forget, I've said this many times, that when you eat ethanol with concentrated tetrosulfuric acid, it produces ethene. Without even telling you the answer should be what? Ethene. That is the final product of ethanol. Are you getting what I'm saying now? Question 32 is what? 32. It said, what is the main type of reaction alkene undergo? Alkene will undergo what kind of? The main type of reaction of alkene is what? Addition reaction. A, addition. B, condensation. C, elimination. D, substitution reaction. The main type of reaction is what? Addition reaction. All together, that is our question 32. Now let's take a look at question 33. They said, ethanol reacts with excess acidified K2Cr2O7. Excess acidified K2Cr2O7. When ethanol reacts with this, what? To produce what? Now, take note of this. When ethanol reacts with this in excess, this is an oxidizing agent. When ethanol reacts with any oxidizing agent in excess, it produces, its final product will be what? Alkanoic. Alkanoic acid. That is when it is in excess. But when it is a limited supply, K2Cr2, when this is an oxidizing agent, when the oxidizing agent is added to ethanol in excess, it will produce this. But when the oxidizing agent is added to ethanol in limited supply, it is going to produce alkanol. Alkanol will produce. Are you getting something now? Are you getting me? It's going to produce what? An alkanol. Why? Because it is in what? In limited supply. It will produce what? Alkanol. Alkanol. All together. Now, let's take a look at another question. That is question 32. Our answer to that should be A, Ethane B, Ethane C, ethanoic acid, and then D, Ethene ethanoic. Our answer should be what? Ethanoic acid. Now let's take a look at question 33. Question 33, it said, the reagent that can be used to distinguish ethene from ethane, I've made mention of this. What can we use to differentiate between ethene and ethane? We make use of what? Ammoniaca silver triazonitrate 5. Or you use ammoniaca copper 1 chloride. Any of them can be used to distinguish between ethene and what? Ethane. That's our question 33. Question 32, 34, sorry. Question 34 is this. It said, alkanol can be prepared by the reaction of an alkene with what? How do you prepare alkanol? Majorly, alkanol are prepared by the reaction of alkene with tetrasulfuric acid. So option A, we have concentrated tetrasulfuric acid. Option B, we have bromine tetrachloramine proethane. Option C, we have aqueous potassium tetraoxomanganate 7. Option D, we have sodium hydroxide. So our answer is option A. That is our question 34. Now let's take a look at question 35. So far, so good. Question 35 is this. It said, which of the following reaction is common to all hydrocarbons? All hydrocarbons. The earlier before I started, I said all hydrocarbon has a common reaction, which is what? Combustion reaction. Combustion reaction is common to all hydrocarbons. Option A, combustion. Option B, addition. Option C, polymerization. Answer is what? Combustion reaction. Let's take a look at 36. 36 said, ethene molecule can be added to one another. Ethene molecules can be added to one another to form a long chain compound called a what? When you add ethene molecules together, it form a polymer. Because a single ethene molecule is a monomer. When you add two or more monomers together, it forms later what? A polymer. So answer to that is polymer. Option C. We have A, dimer, option B, monomer, option C, polymer, and option D, trimer. So answer is polymer. So question 37, so far, we are going. Question 37 says, it said, a colorless hydrocarbon with a sweet smell undergoes substitution reaction. The hydrocarbon is likely to be what? Now, benzene is colorless and it has a sweet smell. Are you getting me? But it is carcinogenic. When inhaled, it is what? Carcinogenic. Are we together? Now, listen. Benzene will undergo substitution reaction. From the question, they said a colorless hydrocarbon with a sweet smell undergoes substitution reaction. The hydrocarbon is likely to be what? A, alkanol, B, benzene, C, ester, and D, methane. Answer is what? Benzene. Benzene is the one that has a colorless and it undergoes substitution reaction. They will just, you want to use that substitution reaction to convince it to what? Methane. Methane undergoes substitution reaction, but it is not colorless. Are you getting me? Now, question 38. Please 37. 38. 38 is that what they said. The liquid hydrocarbon likely to be found in the fraction of crude oil used for domestic cooking is what? The one that we liquid hydrocarbon that we normally use for domestic cooking are there are alkanes. Alkanes are used for domestic cooking. But the first member which is from carbon 1 to carbon 4 are gases. But starting from carbon 5 down, I get it, they are liquid. Okay, I mean like that. So carbon 5 is pentane. Pentane is carbon 5. So all these ones are liquid and they are majorly used as fuel. I guess for cooking, domestic fuel for cooking. Now I said liquid hydrocarbon likely to be found in the fraction of crude oil used for domestic cooking is A, C3H8. C3H8 is propane. B, C5H12. C5H12 is pentane. C, C13H28, that is tri-decay. C20, I think it's called ethane. C20H42 is ethane. So the answer to that is B, pentane. C5H12, pentane, is used as domestic cooking. Now let's take a look at question 39. Then the last question, question 40. Now, question 39 is this. This one is common. They said ripening of fruit is esteemed by using what? What do you normally use to ripen your fruit? It is majorly done using ethene. Ethene is used towards esteem ripening of fruits. Ethene. Why ethane is used in what? Mineral as a fuel in mineral. So answer to that is ethene. We make use of ethene for what? Ripening of fruits. Option A, ethanol. Option B, ethane. Option C, ethene. Option D, ethane. Our answer is what? Ethene. While the last question but not the least, which is question 40. So far, so good. Ethane is prepared in the laboratory by the action of water on A, calcium carbonate, B, calcium nitrate, C, calcium oxide, and D, calcium carbide. Now, ethane is prepared in the laboratory by the action of water on calcium carbide. Are you getting me? When water is added to calcium dicarbide, calcium dicarbide, are you getting me? It produces ethane with plus H2O. Are you getting me? In the laboratory, we have C2H2, ethane. So, when this is added to this, it produces what? Ethane. So, ethane is produced in the laboratory by the action of water on calcium dicarbide. This is calcium dicarbide, CaC2. All together. So far, so good. The 40 question I promised you that I'm going to explain to you that based on my research on organic chemistry 1 is done. Now, in the next video, I'm going to be sharing with you another 40 likely question on organic chemistry 2. Where we're talking about all your alkanoic, alkanol, carbohydrate in special. All together. Thank you. If you are new to my channel, don't forget to click on that subscribe button, share the video with your friends, and also click on the like. Anything you don't understand, just drop a comment for me in the comment box section below. Thank you so much.